Welcome everybody to the Azure and AI Show. With us today we have Hal Holster in the US and Hamashri is in the US as well. And Sabat, where are you located?
Yep. I'm trying to share it. Give me 1 minute.
Okay, just I'm myself, Frank Falvey. I'm here in Ireland. And we have two speakers so far this week with us. So we have Sabat. He's going to do a session on architecting resilience enterprise systems, separation with Azure Cloud and AI-driven testing. And then Hamashri is going to do her session on data-driven microservices for finance, performance, compliance, and AI at scale. Was that the one? Yeah. Yeah, very good. So yeah, I can see your screen there. So Sebas,
Okay.
do you want to carry on there?
Okay. Let me start. Good morning, good afternoon, good evening, everyone. I'm Subhash Lakshmi Velayathan, and I work as a software development director for a company called NGT Data based out of Dallas, Texas. And today I want to talk about one of the most complex challenges in the enterprise transformation, which is a system separation. Okay. So let me move on to the next slide. Okay. Whether driven by mergers, modernization, or a regulatory change, today organizations are increasingly being asked to untangle deeply interconnected systems. The reality it is, most of the failures don't happen because of what we know. This happens because what we don't see it. That is where today the modern AI world moving from a reactive testing to predictive validation. And I wanted to bring few of the related to what I have done it for Azure and AI actually. Okay. Let's start why these programs are so risky. Okay. System separations. Yeah, this can be classified like any company merger and acquisition. You need to move from one domain to other domain, or platform consolidation. Okay, you may be having multiple SaaS or whatever the platforms they are using, which they wanted to consolidate it into one. And the third, it is legacy modernization. Healthcare, kind of a course, banking organization have mainframes and the old systems we have it, which need to transform it into a modern systems actually. Okay, into the cloud. And then with the compliance and regulatory changes, we need to make in actually. The real challenge, what we noticed over a period of time, it is the systems are tightly integrated, and the dependencies, it may or may not be documented, and most of them it is often undocumented actually. And data doesn't always line across the platforms. We have huge dependency with the data, how when we transition from one system to other system. And all depends on how do we validate. The success of this transformation depends on how do we validate. Okay. Traditional approaches will cast certain amount of validation from a business requirement to generating user stories and testing it, but it doesn't capture that end-to-end view of it. That is where, and this structure or a framework which helps out to develop or proactively identify some of that opportunities actually. Okay. Coming back to what is a complexity. Okay. Enterprise system doesn't behave like clean or very modular architectures. How much ever we structure we put in, there are a lot of patches being put in, which is not documented, not unknown actually. Okay, because they evolve over years of complex dependency networks. But when you try to separate them, one broken link may cause multiple failures, upstream and downstream both. And whatever the modular APIs, right, what they built it over the system, it behaves unpredictably. And the data's point of view, it becomes very inconsistent. And the operations get disturbed. Okay. It is not about just a separating system. It's kind of an untangling a web. Without structure, the web, whatever the software we are building, it will not behave what we wanted to do it. And on top of it, we have a lot of external dependencies with vendor, and well, depends on the organization and the application what it is behaving it actually. Okay. So what is the structure? What we are trying to put it is based on that experience. Okay. Yeah, it can be legacy transformation, legacy modernization to cloud, or mergers and acquisition, or platform optimization, based on what exactly the type of it and what software being used, from a sales to service to operations to delivery to standpoint. Okay, it can be a SaaS and different models, whatever it is. What exactly being to be done using this AI and all. Okay, bring in standardization. Okay, this really comes by experience. You put your real solution. What are the systems we have? What are the dependencies we have it? What kind of a deployment procedures we have? What kind of configurations to be done? Okay, so input all those informations into it and bring in standardization. Develop reusability. Train AI model to get that reusability based on what we need. Have a controlled deployment actually. So in short, what I would say it is, it brings in discipline through standardized configurations, reusable templates, okay, structured testing, okay. It can be manual or an exploratory standpoint, we will do it, but at the same time, we build agents to perform the testing as well actually. So it's kind of a structured testing with a checkpoints with human in the loop actually. Okay, so this is not a new context or new problem what we are trying to solve it, but how we can build a model office kind of a framework based on the system, and then how you migrate and ensure we have a reactive validation, proactive validation instead of reactive. That is what we are trying to put it. Okay, now moving on to the next slide actually. This methodology works through a structured life cycle where you have a requirements which will come from a discovery sessions. Okay, from the discovery sessions, we determine what are the systems we have it, where it is interacting it. Okay, so some organization have a master inventory or a master database which will have what system, what are the dependencies, what application platform. Details are documented. Okay, if it is well and good, it's straightforward. If it's not, it is important to, as part of discovery sessions, get all those informations actually. Identify the system dependencies in terms of inbound as well as an outbound. And also the infrastructure standpoint. What is the peak load? When is the peak season? What exactly? Okay. And then risk identification. If they already have a risk management strategy, we should use and try to bring in AI and get that model of risk identification. Otherwise, it's again a manual process. Pretty much today's world, though AI it is there, this is kind of a risk identification is still manual being done actually. Okay. And then after completing that initial discovery and assessment phase, get into a design, how the architecture looks like, what is the integrations, what exactly the configuration templates, what needs to be defined, what kind of data we have and how we need to deploy it. So really design the particular phase actually, and then you build it. Okay, this building is where you have a lot of reusables actually with an AI and things. Okay, so based on what system you use, based on what configuration we have it, it is pretty much we can build the reusables as part of that modelizing, and then integrate using that pipelines, which can be an where in our experience we use Azure data pipeline with the data stored in ADF data factory and files stored in ADF factory, and we build that pipeline, get that infrastructure set up, and then finally do the data transformation testing. You need to move the data from maybe mainframe system to Snowflake, or you need to move the APIs which needs to test on a different platforms actually. So we have used Azure pipelines to transform the data, to validate that API, build agents to automate the test scripts, okay, navigate to an applications, and then also understand if there are failures. The entire end-to-end methodology, it has been automated and bring it actually. Okay. Again, do we have a control? Yes. We progress with control, clarity, human in the loop. Okay. And always need to have a structure in place. Otherwise, if you do not have a structure, it will not go. Next. Okay. From model office to cloud native validation. Okay. This is where the challenge comes with all the cloud migration and things, right? We have a framework available from a structured framework. And how do we can take this framework, directly transform into modern cloud environments? Okay. Where Azure, the pipelines, ADF data, how you transform it, it amplifies the methodology to enable the automation, scale, and intelligence actually. Okay. In short, what Azure helps it is automate the testing pipelines, spin up the environments and demand, fine tune it what we need, do that validation, run continuously. Okay. When we bring AI into the checks, if you really in between, right? Obviously, human interaction is required. Human in the loop is required, because it is not 100% you can trust on it. AI. Build AI agents to build all those things. But when you really, we move from manual checks to a smart automation and intelligent predictive validation actually. Okay. In short summary, we are getting into a mode of from reactive to proactive to predictive model. Okay. So Azure based, this is kind of a structure and an architecture to provide how do we enterprise level, how do we upgrade the testing and validation. Okay. We have an end-to-end validation pipelines. We build an environment which is kind of a production like. Okay. And bring in full observability across the systems. Okay. And do a before cutover, right? It is important to a mock run actually, validation standpoint. You migrate it, bring in day in the life scenarios, run it, and see, then you bring in the cutover timeline changes actually. And in short, test the system with the way it will actually run. Okay. And here, bringing in Azure, bringing in AI, bringing in different frameworks, we can pipeline it. And what are we trying to get over? It is over, depends on the number of projects what we worked on, how the systems are integrated, how this has been organized. We the model office approach, so that we should be able to build out the reusables which we can evolve into it actually. Okay. Next slide. Okay. AI driven. Now let's talk about the real game changer, right? Primarily today it's pretty much all AI driven, right? Does it work? Okay. Where is likely to fail? Okay. With AI, over a period of time, you train a model, whatever we are using it. It can be different LLMs actually. Okay. Propose with an experience. When you train, test, validate, it will automatically identify where are the high risk integration points to focus on it. detect hidden dependencies where we have source to destination where it can break, it cannot be. You predict failure probabilities actually, and then prioritize the testing effort. It can be a risk based or whatever the model what we wanted to test it, right? So instead of testing the full traditional way of getting into it, you have a structure, build configuration, build that reusables, deploy it, and try to focus. A will do with automated pipelines will do a majority of the part, and then human focus should focus on what exactly we should do it instead of testing everything. Actually, it will give some structure on which to prioritize, how to execute. Okay. And four pillars of resilient testing: data integrations, which is you need to ensure consistency across the systems. Then integration testing, validating APIs, events, services, okay, to ensure the connections hold post separations. Performance and stress, okay, system need to scale to validate the at the peak time, peak load, whatever we need it actually. And then by end of the day, which is very very important, focus on business process validation, which is covering from an end-to-end standpoint. Okay, operational continuity is important. Identify the flows. This again domain comes into a picture. I work on a healthcare background on both payer and provider, so pretty much we build a lot of health reusables, enrollment, claims, third-party integrations, payments, remittance advice, different platforms. What we identify that core critical scenarios and build that business process validation to ensure any modernization, any structure, or any separation, IT separation, or a merger, acquisition, it smooths it works smoothly. And today's world, if you really see, right, payer or a healthcare provider, lot of transformation within hospitals. Two hospitals merge and they want to move to one system. Two payer organizations will move and they wanted to use one core system. So a lot of acquisitions and mergers happening where we need to focus on data integrity, integration, performance testing, and business process validation. It needs to be done, and it can be built using Azure and AI actually. Okay. The benefits it is, we have a reusable framework, reusable configuration items, reusable business process validations, which automatically the timelines will get much faster. Reduced separation risk, more reliable integrations, ensure at least a good amount of integrations works fine, and then strong governance and auditability, human in the loop, validating it. And it's not about a technical improvement, it's about a business assurance. Okay. At last, let me leave you with a few key takeaways. Hidden dependencies are the biggest risk. Okay. Identify the risk. When you migrate a system, what fails, where we need to focus our effort actually. Okay. Traditional testing is not just enough. It needs to be scaled as an enterprise level within the particular time frame actually. So automation plays a major role. And how do we build agents, and how do we build automation? How do we build real end-to-end processes, business processes works needs to be getting. Okay. Use the structured framework to have consistency and control actually. Okay. And Azure data, Azure pipeline, ADF, the infrastructure, what we provide, what we have it, it enables scalable and real world validation scenarios. And again, AI will help to predict failures before they happen. It is not about during the transformation, even after the transformation, monitoring it and things which will do it. So the most important point it is, resilient transformation is not just as simple as it's engineered, and it's always to use a best practices and leverage it actually. With that, I will end the presentation, and thank you for your time. I would like to hear about questions and any challenges you faced, or anything which we wanted to bring it up actually.
Very good. Very good presentation. We have one question, maybe two questions came in there from. So I can put it. Can you see your screen there now, or is your screen blocking it?
I'm not.
Can you see this? I'll read it out there. So it's in case of a reusable template. Can you see that one? If a single vulnerability is found in one dependency, then the entire app is vulnerable.
No, here if you see, right, what I meant it over, right, domain plays a major role actually. Okay, when I call about the domain, see, primarily my experience, last 10 to 12 years of experience is in healthcare. Okay, enrollment system, claim system, remittance advice, and similarly provider standpoint, EMR systems. Okay, so when we really find a reusable template, it is the business process point of view, how it is operates, it's pretty much same. Okay, with a slight fine tuning, but systems will differ. So how we can leverage the business processes validation, that is what I meant about the reusable template actually. Vulnerability, how do we test that, right? It's all about an experience. Can a person today build with without experience or without knowledge, can you build a template to do all this configuration? It is not actually. So we find a defect, we find a vulnerability. It all comes from an experience. You find if any issues, find obviously as part of that model office, we do a validation. We ensure pretty much all are covered. It's covered and assess the risk and those things. If it is already, if it's finding it early stage, yeah, it should be. But again, it is not about we can sort 100% or vulnerability which we will be able to fix it at one shot. It's over a period of time. Try to understand, fix it, and then redeploy it actually.
Okay, very good. The same person, they were saying even Microsoft is in plan of banning Claude AI. I'm not sure what they mean by that.
So AI actually today's world, right? See, we use a lot of AI actually, and primarily it's not about using a cloud. Okay, see the advantage of building these automated pipelines and scripts, right? It can be a Microsoft Copilot or GitHub Copilot, Claude AI. Two ways which we can use it. One is you record and any applications transformation or application, right? You record the script and then give to AI, and automatically the playwright or whatever the scripts what we have, right? It will restructure, refactor it, and then give it. That is one aspect of it. But the other aspect of it, yeah, you automate one script. You may have thousands of scripts today with that application today in that world. Okay, you automate one script. How do we store that in a knowledge repository? Build a vector kind of a database, vectorization and things. How we use that knowledge, and then when we build second time, or when we give a prompt to develop that automated script, go to this vector database and then identify what scripts or what screens it navigated to, what business process to be validated. And then you, based on the context, which we call it as a context QA, and develop the test scripts and develop that pipeline and automate and deploy it actually. So it is, see, one is how do we use AI? Obviously, the intelligence brings into picture. It is not just giving any prompt and getting it. Okay, it's all what approach we use, what is the need. It's all again depends on individual perspective, evolving area, right? How to leverage AI, it's all we are all learning and evolving today actually. So hoping over a period of time it will stabilize, but at this point of time, in an exploration phase, and in short, it will help out to reduce that effort, optimize test coverage, and run smooth process using Azure pipelines. All those things will come into picture actually.
So it is mostly in the healthcare sector you were running these. Yeah.
Correct.
So
Primarily, yep. Yeah.
yeah. So what kind of guardrails do you put in place?
What kind of
Guardrails, like
guardrails actually?
yeah.
Okay. So at this point of time, it's all human in the loop actually. Okay. Because see, we have a lot of regulatory and compliances which we have it, right? So whatever it is validating it, human in the loop, we ensure we validate it. Okay, not really system point of view having that guardrails. A is helping out with some, but literally we are not trusting at this point of time because and we find issues with it also, some of those. That is where the model of its structure or reusable and configurations, right? We pretty much trying to ensure stabilize over a period of time. It can be 2 months, 4 months, 3 months. It's kind of a solution which we are building out and ensure we should not get into any fault detection when we deploy it actually.
Okay, so you're just using AI just as helping you out with stuff rather than taking full control of the.
100%. Human in the loop is mandatory.
Yeah, very good. That's great. Hal, have you any questions?
Helps if you turn the dang microphone on.
Yeah.
Yeah. Sorry. No, I have. That was quite a nice presentation. Thank you kindly.
Thank you, Hal. Nice meeting you and everyone. I know it's a different location for you. It's evening, and yeah, it's afternoon. Good. Nice to meet everyone. Yep.
Are you in the? Is it the evening where you are now, Sabash?
No. I think this is the only. For me, it's a 1 o'clock noon, 1:30 now.
Okay, so you're in the US, are you?
Correct.
Yeah. So Hal is 11 o'clock where he is, and he's in the US as well. Yeah. I'm over here in Ireland, so it's kind of a 7:30 p.m.
Yep. Yeah.
Very good. Yeah, it's exciting times, isn't it, with all the AI stuff going on at the moment?
Correct.
Yeah.
It's again, it's a very vast. Okay. So how do you use that? Okay. See, again, as I mentioned, I work on a healthcare, right?
Yeah.
In the healthcare, the major challenge it is you have a data, PHA data. You cannot expose that. Okay.
Yeah.
At the same time, you have a system which you need to transform it. Okay. How do you store the data in a secured environment? That is one layer of it. But you can transform the system, build that pipeline, and then you can play around with it. How do you smartly use it? That is where it is. And then where, data also, right, is not just straightforward, right? You have a data, you need to predict something. Build a model, analyze it, build dashboards, and see, for example, based on last 10 years, what is my enrollment prediction in 2027? I should be able to predict it actually. That use the data for that. But at the same time, don't get into PHA kind of a compliance issues where you literally identify a personal identifiable data or a health information. Though we need to literally segregate it, and those places, what we literally did it is we use a data masking or a data de-identification strategies. Okay. And how did we build it? Again, that is using Azure data pipelines, Azure pipeline. We built a pipeline which will mask the data what we need and then deploy it into another environment and then leverage it. Okay.
Are you kind of leveraging any kind of DevOps when you're doing this?
Obviously. Yep.
Yeah, for the pipelines. Yeah. Very good. What about the agents? Are you using any kind of agents, AI agents?
Actually, see, lang graph we use actually from a point of view, right? We use lang graph, lang chain. We build it using Python, and then call those pipelines, okay, and get on it at this point of time. But yeah, again, it's a Microsoft shop. So if you see test automation, what we have using Playwright, which is again from Microsoft, right? So it's kind of a some patchwork we do it to ensure how do you use it actually. But yeah, overall, but our connectivity from a ADO, call the test scripts, and then call internally will get an Azure pipeline, and then get into the which internally gets that lang graph, uh, the agents to run it, and which will provide the test results back to ADO. All those things, it happened. It's a pretty stabilized framework which we are using to develop.
Very good. Very, very interesting. So it's kind of the same sort of stuff. So we say banks would probably use as well.
Correct, correct. See, one of the previous project, in fact, I was working one of the US migration, which is a digital banking, where you have ATMs, where they sell it. How you they have a sales system called Salesforce, and they have their inventory, full inventory of system. How do we deploy it? Okay, and they manage. They have a software within that organization based out of Azure. How do you manage all those things? And see, from an IT operation standpoint, right, you have a core system, you have surround application, you have an infrastructure, you have a security, different bundles, you have it. And how do we merge and bring everything in one bundle actually? That plays a major role. See, merger acquisition, it's easy to say one company merge and get it, but the system migration is really challenged. That is
Yeah, I can imagine because you would have a lot of legacy kind of systems that you want to try and get them over. So how do you kind of get around those sort of things?
it's an experience, to be honest. Actually, okay, we have an inventory. Any migration, right? For example, an IT migration. What is your sales system using? What sales and marketing system? What is their finance system? What is your integration touch points they have it today? And what the business process validation is one part actually, but there are so many other parts which we need to ensure we check on it. And we build that model of this framework, we build it, okay, to leverage it for the transformation.
Right. When you say you had templates there, reusable templates, would you have a template that will kind of you can apply to most migrations, or would they be?
It can be. See, one example I can say, from a mainframe DB2 database to Snowflake. Okay. So we have a pipeline. Okay. For a healthcare, you have a member data, you have a provider data, you have a health plan data, you have a different type of data. Just map those data to the source template, and the destination, it is a different technology, Snowflake database. You have a different database, right? So we have a pipeline automatically built. You have the source system. Okay, these are the data which we have it. You have a target system. These are the system data what you need to validate. We have a template. Use that template and map those data accordingly, and use this Azure pipelines, transform from one to other system, and run it actually.
Yeah, I see Snowflake was in the news. All right, this week they done a big deal with Amazon. So are they used for migration mostly, Snowflake?
It's a good amount of data being transferred in.
Okay, so
Yeah, but again, the how do we store the files? Why do you, for there we use data lake, ADF, and Azure data lake and things like that. But Snowflake primarily, fortunate or unfortunate, yeah. Those are all architecture decisions. Okay, being used for what? But one advantage it is not platform is not it's a platform independent. Any platform you use it, technology, it's easy to integrate and adapt actually, which is really good today's world.
So when you're doing the migration, as you say, like you're putting all your data into a data lake on Azure, and before you do any lift and shift, we say. So do you kind of keep a whole backup of your system before you do the migration?
Backup, yes.
Yeah, I suppose it's critical, really, isn't it, that you have a backup before you actually break the whole system?
Yep. See, it is not only during the migration or before the migration. See, business continuity is important, right?
Yeah.
Backup is continuously taken, and to ensure, again, some of the complaints is what we have in our it is you need to store 10 years of history of data, 7 years of history of data. So it is important. It can be
Okay.
yeah. So we pretty much have it. And the cutover, right? When we cut over, depends on some depends on what the cutover it is. Okay, it varies customer to customer what we need it. Some of the clients on the day of, for example, 2021 on 27 onwards, my claims will be adjudicated in the new system. I'm putting that cutover. And some it will happen like whatever the old claims, it will still continue with the old system adjudication, and whatever the new claims coming in, it will gather. So it depends on how do you separate it and categorize it, and different depends on the customer need actually.
Okay, very good. I know here back in Ireland, a lot of medical device companies, they actually have to store data on paper, and they have to keep it for something like 15 years.
Okay.
It's a bit overkill, I think, but yeah, that's regulation for you.
Okay. Is there anything else?
Any questions, Hal, for Sebastian on that?
Nope. Again, a great presentation. Thank you kindly. I learned quite a bit.
Yeah. It's all about learning, isn't it?
Sharing and learning. Yeah.
So it must be in the US at the moment, all the data centers that are being built is quite interesting, isn't it? The amount of power that they're using, like, is it affecting any of you guys?
Not really. See, from our point of view, right? I'm not really into that infrastructure side of you. You request for some resources, you place a request, we will get it. We literally not looking into where exactly, what data center, what training location, and all those things. We literally not into it. But we have a backup plan. Okay. See, for example, you may have a multiple centers, right? If one of the centers, we look into it, you have a data stored in one center. In case if there is a disruption in that center, what is the backup actually? So those are all pretty. It's a cloud environment, right?
So Microsoft normally kind of has regions where they might have three different data centers. So if one goes down, you can fail over off another one, and yeah. But no, I'm thinking about, the energy. Is it having any impact in some states? Did you hear anything, Hal?
Not so much energy. Well, that too, but at least in Arizona, it's the water that they need, that they want to use. There isn't a whole heck of a lot of that here, and the data centers, they want quite a bit of it. So for cooling, I assume, and the like, but it's basically one of those not in my backyard situations.
Yeah. I see that there's one Meta are building one there now. I was reading some of the figures on it, and I think is it in Utah that they're building it? It's called Project Stratus, and it's 40,000 acres is the footprint of it, and seemingly the energy, they're actually instead of connecting it to the grid, they're actually going to use natural gas turbines to actually power it, and then by day they have an extra. They're building one of these solar farms right next to it, so that during the day when there's the higher demand on it, they can use the solar then to kind of supplement it. And the power consumption that it's using is just phenomenal. It's 9 gigawatts per hour. Giga. It's not mega, it's giga they're using. It's massive. So you can imagine.
That's a bunch.
Yeah, that is a different world actually.
Yeah. So 9 gigawatts. So you can imagine what's going to do to the environment, the amount of natural gas that they're going to burn there to power up that. Like it's.
Yep, 100% I agree.
Yeah, we have here where I live, we have hydroelectric dam. It's a small one now in comparison, right? But that dam only generates 15 megawatts. So you can imagine how many of those hydroelectric dams we would need to power that station.
Yeah.
So it's like.
Okay. Is there anything else? I think.
No, we're good.
Thank you. Nice meeting you. Thank you so much.
Okay.
Absolutely.
Sebastian, nice having you.
Have a great evening, everyone.
Have a good day.
Yep. Thanks. Bye.
So Hal, it's a quiet one this week. We had 4 speakers lined up, but 2 turned up and one spoke.
Oh well, there are weeks like that.
Yeah. So 3 hours you had last week. My good.
Something like that. Yeah, it was. We started at 11, and I think Dan posted something a little before 2 p.m. my time, which so it ran the better part of 3 hours last week.
Yeah.
So I guess divvying it up with this week being a little bit short kind of averages things out. But
yeah, sure. That's it. 3 hours is a bit long. All right. Yeah.
Yep.
I normally organize the speakers every week, and I was kind of trying to have 3 speakers do 20 minutes each, and that would be the hour, and maybe have a kind of a chat then kind of in between, and that kind of make it a bit social. But the last few weeks it was kind of a lot of speakers. We're going 2.5 hours, 2 hours, going way over time. So and it's kind of hard to try and keep people here for 2 hours or 3 hours.
I hear you.
Yeah. So we'll cut it short this week. So Hal, and listen, thanks very much for joining us. And
absolutely
interesting to hear about all your equipment behind you.
Absolutely.
I used to have years ago the CB radios. You know those ones?
Oh yeah, that's everybody kind of gets has at least a brush with that when getting involved. In my case, it was I had an uncle that had ham radio, and he and his family had a ranch here in Arizona about 30, 40 miles from where I live. Nevertheless, we out there visiting one day, and he's got the radio going, and I just got so ridiculously hooked on it.
Yeah.
I really didn't think much of that at the time. I wound up there was in fact, I think it's still being manufactured. There was a magazine called Popular Electronics that was quite popular when I was a kid, and they featured a lot of the CB stuff. And so I got interested in that and got to bugging my dad about, hey, what about one of these things? And he's saying, well, no, what you really need to do is go talk to the ham radio folks. It's a little bit different, and it's a whole lot better. And it turns out that some of his friends, well, the guy that was the the foreman for the repair department for the local Sears and Roebuck store, and the local TV cable company, and a few others were run by them. And I wound up meeting them and getting involved. And like that, gosh, that was in what, 1964, 65, something like that.
Wow.
It's been so I've been playing with radios for well over 50 years.
Yeah, I knew a few guys here in Cork, all right, they used to be into ham radio, but you had to get a license. And
Indeed.
you had to be kind of qualified in electronics. They used to do a course in the university where they
Fascinating.
would be able to repair their circuit board if anything happened. And did you have to do anything like that?
As far as the test is concerned, yeah, everybody has to go through that. That was the nice part about being getting involved with the people that I mentioned. They had a club. In fact, even today, there are lots of ham radio clubs. There's a big one here in town, and as far as the testing is concerned, they put on training courses to teach you the stuff. They are also the examiners. The Federal Communications Commission no longer does the testing. It's left to a bunch of volunteer examiners that are ham radio people that are at the highest license levels and so forth. But you still have to take the test and pass that. But I mean, there's really kind of good to that. It's kind of how I got my job. As I say, I had the license and well, gosh, I've been playing radio for a very long time. Most of what I did here in the city was fixing TVs and stereos and stuff like that there, until I made the acquaintance of what was the chief engineer at the TV station where I wound up working. And he's a ham. And as it turns out, everybody who was in the engineering department were also ham radio operators. The idea being that if a private individual was willing to go through all of the pains and trepidations and problems of going out and learning radio theory and then passing a test, on just on your own volition so that you could go play, maybe such a person would make a good engineer if they got paid to do what they went out and took this test to play with. And so it was one of those things. I one day was driving around talking to him on the radio, and he was complaining about the fact that one of his people, who was a ham that I knew, was going to leave KVOA, but the TV station was going to leave and go off and work for yet another ham that I knew who was head of the county communication services. So he was going to go work for Pima County. That's the area of Arizona I live. And what was he going to do? Oh, woe is him. Oh, woe is him. He just had nobody. And finally, after listening to this for several days, I basically said to him, "Hey, look, if I had the commercial license, I would come down and talk to you." And he says, "Why don't you come down and talk to me anyway?"
All right.
And so I went down and talked to him and pretty much got hired on the spot. But I don't have the license. He says, "Well, no, what you're going to do for the first couple of months that you work here is you're going to sit in that room over there with this stack of books, and you're going to learn all that stuff. And then you're going to go take the test at the first convenience. And then everybody's going to be happy." And that's pretty much what I did. I got paid for 2 or 3 months to just sit in the room and read books and make sure that I knew all the theory and so on and so forth. And it wasn't easy. I went from no license to first class commercial license in one sitting. And that's about 250, 300 questions, because there's like a third class, a second class, and a first class. And I mean, The first two were like 50 questions each. The last one was like 150. So it was quite a thing, but I wound up with the license, and I wound up with a job where I stayed for 34 years.
24
And how that worked out to get into the world of computers is simply the world of computers came knocking on the door one day. And then it said to the folks in the TV station, you must have these. Because that's where the world is going.
So that's where
the TV station looked around and everybody said, well. And so it was because of I had gotten involved with computers, the good old TRS-80 Model 1. First, shortly after joining the TV station, there was a guy working there that had one. And he brought it into work one day. It was a fully decked out. I mean, you could spend as much on an old-fashioned TRS-80 Radio Shack computer to get all the bits and pieces and parts and so forth as you could on a PC. You could spend thousands. And he apparently had done that because his was fully decked out. And he had this stupid game. It's not the Scott Adams that made the cartoon. It was another Scott Adams, but he made a bunch of little adventure games. They were all text-based. Hi, you are in this field. Your directions are left, right, up, down, so forth. What do you want to do? And I got blisteringly hooked on this thing. So much so that I wound up, I had to go and have one. So, out comes the piggy bank and the hammer. And we go and we get ourselves one and deck it out far enough that we can play this game. And we're having a gay old time and the wonderful stuff. And then one day it quit working on me. I had a screen full of letters where there were supposed to be spaces. And I was just so horribly disillusioned and upset that this new toy I got had just broken on me. And woe is me once again. What am I going to do? And the lovely fellow that I was that had the original, he says, well, it's telling you what's wrong with it. And I said, well, how do you mean that? He says, well, look at the screen. Okay, what you're supposed to be seeing is spaces. That is in hexadecimal, a 20, the number 20. And he says, so what you've got on there is this letter. Let's take the binary from that letter and compare it against the binary for a space. And I got to looking and I said, well, yeah, okay. There's this one bit that's high that's a 1 that should be a 0. And he says, well, there's your problem. What do you mean? That bit is stuck. You have a bad memory chip. As it turns out, the screen memory was 1024. It was a bunch of 21 LO2s, 8 of them, which is a 2K by 1 static memory chip. And and he's saying the one that's in this position is bad. Replace it. How can that possibly be? All right, if you say so. So out comes this, board box comes apart, and out comes the circuit board, and carefully we pull out this one chip, counting 1, 2, 3, 4. Okay, that's the right bit right there. Pull the chip out, put a new one in, put the whole thing back together, and it works.
Wow.
And it's like, wow. Not only they'll tell you what's wrong with them if you know what questions to ask.
Yeah, so that 20 was the error code.
Well, no, 20 is the hexadecimal for a space.
Oh,
that's
yeah.
ASCII for a space is 20 hex. I think it's 32 in decimal. I'm not real sure. I can't do that in my head that well anymore. But the whole point of it is the machine told me exactly what was wrong, where it was wrong, and what I needed to do to fix it, simply because I suddenly was instructed in what binary and hex and all that stuff actually worked like.
Okay. Cool.
And so it was downhill from there. I was the quote computer genius, end of quote, And so when the world of computers came knocking at the door saying, "You need this," they all looked at me and said, "Hey, do this for us."
And
And
how did you get into becoming a Microsoft MVP then 30 years ago?
actually, working along with the same thing, I was suddenly the guru, and we set us up first a Windows 3.11 Windows for Workgroups work group that got augmented once NT3.5 came out into so it got updated. I don't know if that's when I don't remember whether the 3.5 or it was 4 where you actually started using domains. I forget exactly which, but nevertheless, we had a problem back then in that we had this internal network, and it we had an internal post office that Microsoft was the work group post office, which basically comes free along with the system. So we set a machine up as the post office, and everybody had internal mail, which is fine, except that it didn't go outside the building. So we needed internet mail to go with it. At the time, the ISP that we had said, "Yeah, okay, we'll give you pop mailboxes," and so you wound up with 2 different mailboxes. You had an internal one and an external one, and everything coasted along just fine for a while. They gave us like 100 pop boxes. Unfortunately, they never counted on, and we never really explained to them, I guess, what was involved with a news department, or for that matter, a production department. News departments are the worst. The turnover. People come in, they stay for a little while, they leave. There have been a number of, well, the big thing, in fact, I'm not assuming that the news has made it over there, the issues with Savannah Guthrie and her mother being kidnapped here in, well, gosh, Savannah interned at the station where I worked.
Oh wow!
So you know, it's just the turnover was pretty constant.
So
And we would run out of mailboxes, and we wound up then at that point the ISP would take to develop a new pop mailbox took them a darn near a week. This was unacceptable. We just couldn't do that. So I got to looking around, and on the 3.51 resource CD that they included with the operating system itself was a small pop SMTP post office. And oh, hey, that's kind of neat. Let's play with that a little bit, see what we can do. So I got the thing set up and did some testing on it using the what was then the Windows 95 Exchange client. That turned eventually that became Outlook Classic after many years and many iterations, but there was an issue. I mean, I could send mail, but I couldn't receive it. And I would watch, these things on the back end, actually on the wire, there is ASCII commands and responses, hello, EHLO or hello, whatever, and then ready this, send data, data received, back and forth. There's this lovely little communication that would happen. And what I was experiencing was the client would say, send me an email. The server said, okay, here you go. It would send the email, but the email never got there. It never got there. That's not what the client said, though, because the transaction completed. As far as the whole world outside knew, I had actually received an email, but it never got there. So I wound up going out into what was then it was msnews.microsoft.com. It was a Usenet NNTP service where you could go in and out and ask questions. And I went in there to try to figure out why my little experimental post office wasn't really working. I never really did get an explanation to that after back and forth and up and down and talking to Microsoft, and questions in the news group. So it finally came out, oh, you got that off of the Resource Kit CD? Son, that there software, it ain't supported by nobody. Bye. Well, while I was there, though, the thing of it is that there were questions. There were lots of questions in this server. And I mean, a lot of them, it's like, oh, I know the answer to that. Like, oh, what the hell? I'm not doing anything. Okay. So I type out the answer and post it and find some other questions. Oh, I know the answer to those too. Hey, you know, this is actually a little bit kind of fun. It's kind of fun to do this. So I just started answering questions, and lo and behold, a friend of mine who was an MVP, I didn't know that, didn't know what one was, but got a hold of me and said, you know, you're answering questions and stuff. How about you become an MVP? And I said, well, what's that? Oh, wow. Well, it's this, that, one thing and another. And yeah, okay, that sounds like fun. Let's go ahead. And so she sponsored me. And in November of 1996, I got the word from Microsoft, hi, you are a MVP now, my boy.
Brilliant. Excellent.
And it's just been pretty much downhill ever since. I answering questions in news groups is almost kind of therapeutic, you know. I mean, if I'm having a bad day or things aren't right or whatever, I'll head off to the news group and find some questions to answer, and it makes me forget about my problems. The world seems to straighten itself out. Things aren't as bad as they were. They don't look as bad or seem as bad now as before I started talking. So that's
very good.
That's kind of how it goes today. And where does it lead to? It leads to things like this.
Yeah.
You know? So, here we are answering questions and making the world a better place by disseminating knowledge and our friendship and our desire to help people.
Yeah. So how would you believe it? We made the hour over the hour.
So well, great. Okay.
Me
and my big mouth, I'm good at that.
I'm going to end the live stream, and you bet I'll have more questions for you the next time. We'll be back again here next Saturday. And anybody has any questions for Hal, pop them in the LinkedIn, and we'll be happy to answer them.
Absolutely.